derivatives using chain rule. In this page, first we are taking three examples. The first problem is the square root of 3x squared minus 6x plus 6. We'll take the derivative so we can apply power rule. First we see what is the exponent on this problem. So we see that it is 3x squared minus 6x plus 6 to the 1/2. Now with the power rule, we write 1/2 and then 3x squared minus 6x plus 6 to the negative half, because 1/2 minus 1, and then we need to take the derivative of inside, which is 6x minus 6. Further, if we distribute this 1/2 inside, or if we factor out 6, that will give me 3, and then 3x squared minus 6x plus 6 to the negative half, and then x minus 1. Further, if we write more simplified version of this, it will look like 3 of x minus 1 over square root of 3x squared minus 6x plus 6. We are done on this. Now we'll go to the second example. Example 2, we have our function 3x squared minus 6 tangent x plus 6 to the half. With the power rule, just like example 1, we have 1/2 3x squared minus 6 tangent x plus 6 to the negative half times the derivative of inside will give me 6x minus 6 tangent x will give me secant squared x, and the free constant 6 goes to 0. Now the simplified version of this one could be written as, before 6 you factor out, you get 3x minus secant squared x over square root of 3x squared minus 6 tangent x plus 6 in the denominator. We are done for problem number 2. Now problem number 3 is very simple. We have cosine x, so derivative will be f prime x equals negative sine 3x squared minus 6x plus 6, and the derivative of the inner function will give me 6x minus 6. We are done in this part. Now in this page we have 4 more examples. Number 4. So the derivative of sine x we know is cosine, and whatever we have we write it. Now we need to take the derivative of inner one, which is 6x minus 6 plus e to the x. With the chain rule we are done. Number 5, f prime x, we know square root meaning is 1/2 exponent 1/2 3x squared minus 6 tangent x plus 6 to the negative half, and then 6x minus 6 secant squared x. We can leave like this, or we can further simplify and write 3x minus secant squared x over square root of 3x squared minus 6 tangent x plus 6. So we are taking number 6. So this function is cosine 3x squared minus 6x plus natural log of 2. Remember, natural log of 2 is a constant. So then the derivative will be f prime x is negative sine 3x squared minus 6x plus natural log of 2, and then the inner one will give me 6x minus 6, and we are done for number 6. Next I'm going to number 7. This one is cosine squared, so we have to be careful now. We have f of x equals cosine 3x squared minus 6x plus 6. We can write as squared outside. So then derivative will be now 2 cosine 3x squared minus 6x plus 6. We need to take derivative of this whole, which will be negative sine 3x squared minus 6x plus 6. Then we have to take this part now whole here, which will give me 6x minus 6, and we are done for this part. In this page now we have 3 more. Number 8, we know the derivative of cosecant x is minus cosecant x cotangent x. So this one will give me negative 3, this one will give me negative cosecant 5x cotangent 5x, and the derivative of inside will give me 5. So I get negative 15 cosecant 5x cotangent 5x, and I have another term here. So derivative of secant x will give me secant x tan x. So secant 2x tangent 2x times 2. So then this gives me plus now 8 secant 2x tangent 2x. We are done for 8. Number 9, minus cosecant sin x. So the derivative again, to remember, cosecant will give me negative cosecant x cotangent. So this negative will be positive. Now 4 cosecant of sin x cotangent sin x, and then derivative of sin x will give me cosine x, and we are done. Number 10, it's a little different. So this whole thing we can just say x to the n. So the derivative will be 3 over 5 and then 3x minus 5 over x to the 3 over 5 minus 1, and then we have to take derivative of inside, which is 3 plus 5 over x squared, because we know derivative of 1 over x is negative 1 over x squared, and we are done.